Hello and welcome to the Powerstaxx Plus basic video. In this video we'll tell you some of the basics of how to use the Powerstaxx Plus tolerance analysis software. And let's get right into it. When you open up Powerstaxx Plus, the Dimensions tab, see it named down here, is where you start out. And this is where you enter the dimensional information for the features and parts of the assembly that you are doing a tolerance analysis on. And we'll get right started. We'll do a very simple one, and we'll just say, how does a pin fit into a hole? Doesn't get much simpler than that. And you notice over here, each of these rows has a dimension ID. They're grouped by parts: part A, part B, part C. And we'll get going. One of the first things to know about Powerstaxx is, for the most part, you enter information into green cells. If it's not green, you probably don't enter anything into it. There are a few exceptions which we'll get into in this video and other videos. So we'll get started. Enter the part number. We'll call it part 123. Revision 1. Part name, simply pin. Part material, we'll call it steel. Dimension description, pin diameter. A lot of these things are not absolutely required, but they're helpful and handy when you're doing things. And zone B2. And in here, this is what you really need. Obviously, the dimension. We'll call it 1 inch. We'll call it tolerance of 0.003 thousandths of an inch. And you'll see that this converts over to here. This is what actually is read and transferred to the other sheets. The reason we have a separate column is so that it allows for changing units from English to metric. And we'll talk about that more in a different video. Over here, you see the max and min and times used. Powerstaxx, the associative feature of it, keeps track of how many times the dimension is used. Obviously, since we're just starting out, it hasn't been used yet. And we'll move down to the next one and fill out the next row. Call this part 234. We'll call it Rev 2. Part number, we'll call it plate. The material, we'll say it's brass. And now we're going to say it's the hole diameter. We'll say this is in zone C4. And what size is it? Well, it's got to be something bigger. 0.0007. And we'll have a tolerance of 0.002. And that's it. So now all the information that you need is filled in on this Dimensions tab. There is more information on the right, but again, we'll go into that in later videos. And so now you're ready to move on to the Tolerance Analysis tab, which is down here. Simply click that, and this pops up. Since we are just starting, we have some header information to fill out. Notice that those cells are green. When you fill them out, the green goes away to make it look a little neater when you're working on things. And we'll call this Rev 4 or 3. And we'll enter today's date, January 12th, 2013. Created by Bert. And okay, so we've taken care of the header section. Now we're moving into the first stack up and enter what is being evaluated. What do you want to know? Will the pin fit into the hole? Pretty simple. And so after you fill that in, that goes to black. Trying to keep this neat and clean looking. Little pop-up window there tells you what to do. We enter the dimension ID A1 and dimension ID for the next one B1, and you see all the information that we entered on the Dimensions tab gets populated here. Also notice that in this column, the direction and impact, that cell goes from white to green to help you know that you need to do something there, and we just need to indicate how that particular dimension is added or subtracted in the stack up. So with a pin in a hole, the pin is going to be negative, the hole will be positive. And that is it. So now you've got your dimensions added, and the rest is just little helpful things. So what is required? We'll just say we need clearance. So our lower limit would be 0, and looks like we're good. You can enter in here, enter the date that you edited it. We'll call that today's date again. edited by Bert. We've got a default lot size, and that's it. So a couple other little quick things. Down and see a nice little bell curve shows up. We have our lower limit that has been set is showed there. If we add an upper limit, let's just call it 10,000ths of an inch, and you'll see that shows up, and we get a little bit of red indicating that some things are predicted to be out of specification. If we change the lower limit to 03, so we'll see that just this turns red, indicating that we're not meeting the tolerance, not meeting the requirement according to worst case stack up, but we are meeting it according to the root sum square stack up for the lower limit, and we're out of spec for both on the upper limit side. And you got the little cell there that says out of spec to help you out. These cells tell you how many rejects per lot are predicted. Get some standard deviation, CPK, and CPK data for the assembly. And that's it. Thank you very much for tuning in, and hopefully you'll look at the next videos. Thank you very much.